First of all, I'm super thrilled to be here with you guys. So I want to tell you a little bit about the journey that LuxQuanta is having in this quantum realm, and in particular, how we are helping secure communications, harvesting the superpowers of the quantum universe. So, as you can imagine, if we talk about communications, security is one of the primary things we need to have. Is fundamental to ensure that the telecom industry is healthy. So that's the reason why whenever we speak to each other, we try to somehow hide, and Rotan was talking about at the very beginning as well, we encrypt the information, which means that we somehow break it down to little pieces that are illegible, but not in a random way. We actually do it following some kind of pattern. That way, the receiver can actually reassemble the information by knowing that pattern. So that pattern is the key, the famous key, and that's what cryptography does. The cryptography applies mathematical algorithms to be able to build these keys. So far, so good. Now, the thing is that the mathematical problems that we use today for this cryptography field are very robust when we think about the computers that we have right now, alive. But our other speakers have been talking about this quantum computing, which means that they are using the properties, the quantum properties and the quantum superpowers to boost the ability of these machines, okay, to compute things. So right now we talk about qubits, Rotem talk about it, and right now we're talking about 100 roughly qubits. This is where the world right now is fighting for. Is they are trying to escalate the number of qubits that they have in the computers, in the quantum computers, to reach that level around 1 million, maybe more than that, when they will have enough computing power to crack the cryptography, the mathematical cryptography that we have today. And that's when we're going to be in real trouble. When this is going to happen is unclear, but we know that there is a lot of money, and that was also mentioned before, being invested right now in this ridiculous race to make these computers super strong, these quantum computers super strong. So what can we do? Well, I like to say that the best way to fight fire is with fire. So if we have super quantum abilities to break cryptography, let's use super quantum abilities to protect ourselves. So this is what we do at LuxQuanta. We work with this technology that is quantum key distribution. And Rotem talk about it. It's about at the very beginning when the transmitter and the receiver, they want to set up this key. So there is a conversation that takes place before we start encrypting or decrypting the messages. It's just, okay, buddy, let's agree on which key we're gonna use, not to keep our message very secret. And this is where we use the quantum properties of photons in this case. So we basically make them super weak, so they enter into the quantum realm. And then it happens what Rotem explained at the very beginning. If anybody tries to get into that conversation where the key has been established, because it's in the quantum realm, if you try to sneak in, they both will know. So they will discard this key because it's been compromised, and they will try to set up a new one. So this quantum key distribution technology is not super new, meaning there's already a version out there that is being commercialized for many years. And what LuxQuanta is actually doing is building a flavor of this technology that is even easier to build and easier to commercialize and easier to install and deploy. So this snapshot is just to show you what quantum key distribution means. It's actually a piece of hardware that contains inside the machines that are going to bring the photons into the quantum realm and have superpowers, and also a lot of FPGA as well, technology and software technology as well, that is going to make this unit that you see over there in the slide communicate with another unit, and for both to set up this key. So this is going to be living in a rack, in a data center, and it's going to be used, we believe, across the entire world, because this threat that quantum computing represents affects us all across the entire world. That's why there is a huge race as well to be able to have these systems deployed everywhere. And we are talking about a lot of institutions that they have to make sure those communications are safe. So that's why this technology will go into governmental institutions, banking, health infrastructures as well, you name it. Wherever we are sharing delicate or just our information, like in a data center, that has to be protected. So this is what we're doing right now in LuxQuanta. And this is where actually I want to tell you the story of how we were born, because even though it's a relatively new company, it was born in May last year. The truth is that there were a group of very smart people at ICFO doing their PhD and researching about how to do QKD more easy to deploy. So after 4 years being incubated, that's when basically the company was set up, and that's when we start, fighting to commercialize our products. So this is important for you, because if you look at the core of the quantum team right now, we're 7 people. The core of it is really smart folks with PhDs and a lot of background, very strong on quantum programming, software, you name it. So it's really impressive. But any company actually not only needs these super smart people, they also need other kind of smart people. I want to consider myself one of them, that also help with other things that we also need to do, like all the market development, all the marketing, that commercial stuff, and also administrative stuff. So the reason why I'm telling you this is because I really believe that the quantum mechanics applied to any technology is super, super exciting. If you love to be working on the state-of-the-art stuff, if you want to be ahead of the rest of the world, if you want to work on things that are almost science fiction, I think you should consider going into this quantum universe. And it's not only quantum communication. There are other parts. There is quantum computing, we mentioned it, and quantum metrology, many areas where you can flourish and develop yourself. And remember, not only going to the classical, super cool research type of profiles, but also in these so many others like my own. So if you wanna enter this universe, make sure that you contact us as well at LuxQuanta. We would very much love to hear from you.